All right, so our first unit, we're just going to hop right on into it. Our first unit in this class is all about functions. All right, so you guys have been learning about functions since middle school, but we're taking what you already should know or maybe remember and going a little bit beyond that. All right, so this could be anything from transformations, operations, key features, things like that. Now, before we actually get into the new stuff, I want to take a minute and review the old stuff. All right, this is stuff that you learned probably back in Math 1 and Math 2 about functions. So we're going to do some of these together and some of them on your own. All right, so let's just hop on into it. Now, in terms of participation, just so you know, sometimes I ask for volunteers and sometimes I just use my random name generator. All right, so please make sure you are prepared. And now, even if you don't know, that's okay. We can talk through it. All right, so at the very least, try. Okay. All right, so with functions, remember the whole basis of functions is input output. You put something in and you get something out of it. It's like a machine. All right, like a factory line. So, for example, let's just say I had y is equal to 2x plus 1. Does anyone remember, back from either Math 2 or Math 1, which one of these two variables is my input? So which of these two variables, so x or y, which one do you think is my input? So what I put in? X. It is x. So x is your input. That's what you plug in typically to get your output, which is your y. All right. Now, why do I bring this up? The very first thing that we're going to talk about is evaluation of functions. All right. So the very first question asks us, if we're given f of x, which remember that's another name for y. So f of x, oh, come on. So f of x is equal to negative 2x squared plus 3, and they want us to find f of negative 3. Now, take a look specifically at this notation. What is the negative 3 replacing in f of x? It's replacing x. So if it's replacing x, what do you think I'm going to do with that negative 3? Plug it in for x. That's exactly what you're going to do. All right. So since negative 3 is it replacing that x, that means we're going to take this negative 3, plug this in right here for x. All right. So we're going to plug in for x is equal to negative 3. So f of negative 3 would be equal to negative 2 times negative 3 squared plus 3. Now let's talk order of operations or PEMDAS. What comes first? Order of operations wise. You forget there's a poster over there. What comes first? So technically parentheses come first, so we don't, even though there is parentheses, this is just more of a separation tool. So what do we actually do first? Exponent. So I have to do negative 3 squared. What is negative 3 squared? Positive 9. Why is it positive 9, not negative? A negative times a negative is a positive. Remember, negative 3 squared is the exact same thing as negative 3 times negative 3. And negative times a negative is a positive number. If you square a number, it should always be positive. All right, so this would now be negative 2 times positive 9 plus 3. What do I do next? Comes next in PEMDAS after exponents? multiplication. So I do negative 2 times 9, which is negative 2 times 9, negative 18. And then I just add the 3. So what's negative 18 plus 3? Negative 15. So that's what's equal to f of negative 3. Now, why is this important in math? We essentially just came up with a point. All right? So if I actually graph this equation right here, on that graph, the graph will go through the points negative 3, negative 15. All right, we literally just calculated the output given its input. So if we're given the x variable, we can find the y variable as long as we have the original function. All right. Any questions? All right. So that's just a simple evaluation. Any questions on that? Not too bad, right? All right. Now, which of the following sets of coordinate pairs is not a relationship where y is a function of x? So, function is kind of used as a very loose term by a lot of people, but it does have a very strict definition. Does anyone remember from either math, I believe it's math 2 or math 1 when you learned this, what makes a function, or how you can tell if something's a function? Give me a hint. Some type of test that you would do with the graph. Or what's called has the word test in the name. What's this? Not a pen, but it makes a line. What direction is it facing? It's vertical. Vertical line test. All right. That's one way. That's if you have a graph. But what does the vertical line test actually check for? So, with the vertical line test, you're making sure that at no point does your function cross more than once. All right, so if I go from left to right, it should not cross my pen at any point. The graph should not cross my pen at any point more than once. All right, so is this a function? Yes. What if I did this? Is this a function? No, because it crosses here and here. All right, now, since it crosses at 2 different points here and here, what do those 2 points have in common? It's not their y value that they have in common, it's their x value. So, what makes a function a function? There's no repeating x's. So, if there's anything you should remember about functions, it's the fact that x's should not repeat. Y's can repeat, we don't care about that. But x values do not repeat. That's what makes a function a function. What's up? All right. So what I want you guys to do is look at all the points in each relation. You're looking for if any x's repeat. If they repeat, they're not a function. All right. So There should be only one of them where it's not a function. So take a minute on your own, figure out which one of those sets is not a function. You can talk to your group mates. Sorry.